Good morning. Can you hear me? And I hope you can hear me and you can see me, and we will start. If you, yes, good. Okay, that means this is the exam 2 review, and this is the second session. You had the first session yesterday, and today is the second session. If you have any question, you may use the chat box, and you can ask me, and almost any time. And I can watch the chat box, and I can answer your question. Because when you reviewing, I hope, you probably have lots of questions. Okay, that means just a few things. The exam, as always, will be open Thursday, July 4th, and will be closed Monday, July 8th. And of course, the due date, just to clarify, it is Monday midnight, but we have to be careful because the test, in order to take the test, you need 100 minutes, okay? That means we can't, because I've got a few emails that, the due date is midnight, and then you're saying that it's 9 p.m., because at Examity, you need 100 minutes and also extra time for all of the settings and the conversation with your proctor. That's the reason that the Examity set up the 9 p.m. as a last time for your appointments. Okay? Because you like 11:30 or a few minutes before 11, because then everything will be locked at midnight, and then you will be not able to finish. Okay? That means it is still midnight, but midnight is the submission deadline. In order to submit, you need more than 2 hours. Okay, we know that. And of course, to get ready, I will really recommend that you will take all of the sample tests, practice midterm 2, and the additional practice, which is the last summer test. It's excellent source of problems. Okay? And if I will be you, I will even start today. Hopefully you did start. You already started. You can print the sample test. You can take it, like try to mimic the normal exam environment. No notes, no phones. You can time yourself 100 minutes, take the test, and then check against the solutions. And if you have mistakes, and if you have some like incorrect answers, and let's say your overall score is like 50%, yeah, then is the signal that if you will not practice, probably the actual test will have similar score. That means then practice again and again, print another test, also take it. Okay, just please practice. Also, the weekly quizzes are the excellent source of review problems, because the style is still the same. And you will have, again, 20 problems, each multiple choice, and each worth 5 points. Okay, that's everything. That's what we will do today. I believe yesterday's session, you finished, you did practice sequences, which is the first section in chapter 11. I think I have a few sequences that maybe we can go like really quickly like through, and then we will start from section 11.2, which of course is everything about the infinite series and all of the tests. Okay? And then the last section is 11.6.7, but 7 is just the summary. Okay, that means let's start. I will look at my different screen. I will stop the video. I will put the video on at the end. Okay, that means I will move this a little bit, and let's see what I have. That means let's see if you learned something yesterday. This is just the sequence. That means I know that this section was covered yesterday, but just as I said, just really quickly. Please remember, when the question involves sequence, we do not use any tests. Sequence means that we simply have to find a limit. And as simple as it is, if the limit exists as a finite number, then the sequence is convergent to that number. If the limit doesn't exist or is infinity, then we can call it divergent. Okay? But please do not apply any tests. All of the tests, everything starts from section 11.2, and of course, it's related to series. Okay, let's look at the first sequence. 2n plus sine of n over sine square of n. That means hopefully you know right away that the limit at infinity is just 2. Okay, because sine of n, sine square of n, the maximum value is like 1. That means they're not really changing at infinity. That means that's the leading terms. And since they are the same, the ratio of the leading coefficients matter. 2n over n is 2. That means it is converges. I mean, the sequence converges to 2. Another one, can you tell me this limit? Also, look at the, oh, we have, Ramiro, we have to be careful. It is 4n over n, but we still have outer function. Yes, I can say this. Actually, this is equal to. It's square root of 4, yes? Correct. Another one. This one includes the parts -1 over n, which always is a little, we can be a little bit less, I mean a little bit more confused. Hopefully not. But also looking at like the function on the top and the function at the bottom, we can see the bottom grows to the infinity. That we have like 1 minus 1 or 1 plus 1. And that we have like 0 or 2, 0 or 2, but this is not changing at all. It's like oscillating between 0, 2, 0, 2. But this is like infinity. That means one of the terms are 2 over infinity, another every other one, it's 0 over infinity. But 2 over big number, of course, is small. Yeah, that's because again, denominator has function that grows to the infinity quite fast. Okay, that's the reason. Faster than numerator. Okay. Converges to 0. And this one, the same. Of course, when I'm writing this, I definitely mean that n goes to the infinity. Yes, we're computing a limit at infinity. Okay, can you tell me this limit? This one is nice. You can just think that n is infinity. Okay. That means we will have e 1 over n. If n is infinity, how the expression 1 over n behaves? Oh, what is 1 over infinity? It is 0. Oh, my writing. That means this is 1. And how inverse tangent behaves at infinity? Do you know inverse tangent, arctangent? It's pi over 2. Yes, I was going to draw, and we do have a limitation. Of course, we're just looking at the positive part, and actually not even that. Tangent, inverse tangent at 1, inverse tangent at 2, 3, 4. Yeah, we just follow the same pattern. That means this value, it's pi over 2. Okay, pi over 2. Let's flip the number. This is the limit. Converges to that number. Okay, we can see it's like a normal, like regular limits, I would say. Okay, do I have another one? Okay. Natural log of n and log base 7 of n. Okay, that means this one, when we think about the limit at infinity, let me put ln of x log base 7 of x, and x goes to the infinity. We definitely have indeterminate form, because the logarithmic function at infinity is infinity. That means you may, in order to find a limit, we may use the L'Hopital rule, or we may try to change the base for one of the logarithms, probably the base 7. And then hopefully we will be able to simplify. That we remember, changing the base, we have log base a of b. Let's say natural log of b and natural log of a. That means that's A. That's the changing base formula. Okay, that means I will skip the L'Hopital rule. And I will try natural log of x. And now I have x here. X corresponds to my b. I mean, I can say ln of x. And a, it was base. Now I can put as a input ln of 7. Okay, and we have really nice ln of x and ln of x could be cancelled out. But let's this. Natural log of x, and dividing by fraction means multiplying by the reciprocal. And I can cancel out, the final answer is natural log of 7. It's just a finite number. Converges to natural log of 7. Okay. Okay, and let's see something else. Oh no, I don't have. Okay, that means this was just a really quick a review of section 11.1, which you actually had yesterday. Okay, this, I believe I see the sigma symbol. This means that we're starting section 11.2. That means 11.2, we did introduce the infinite series, and we did have a few properties. And for example, this one. Let's see if we can answer the question. If the infinite series summation a sub n is equal to 1, then find the limit at infinity of natural log of a sub n plus 2 over 3 minus a sub n. Okay, and what do you think at first? What you can tell me? Do you see one of the option that is good for this limit with the given condition? Of course, if you don't feel comfortable, you don't have to say anything, but yeah, because we remember like the property that we're looking for. Okay, we have the first brave student. Tyler said A. Oh, hang on my screen, A. And actually, okay, we have another one. Aryaman said D. Okay. That means, of course, D is incorrect option. It's the mean option, okay? And I think A is the correct one. That means let's see what property we're using. If we have this information, okay, the infinite series is equal to 1. The summation of all of the terms, a sub 1, a sub 2, plus a sub 3, and so on, it's actually giving me the finite number. For this type of question, doesn't really matter what is this number. I could put 1, I can put 100, I can put negative, like, I don't know, negative 5. I can put anything. The only message from this box is that this infinite series is convergent. And I'm not using that value 1 at all. No, this infinite series is convergent. And now the property. If the infinite series a sub n is convergent, then limit of the sequence a sub n at infinity, it's always 0. Always. That's what we're testing, the really important property. Okay? That means if we know that infinite series is convergent, then the limit at infinity of the sequence is 0. Please remember, the other way is not true. Okay, the statement is false. What I mean, if the limit of the sequence is 0, then we cannot conclude convergence. If the limit is 0, theoretically we know nothing. We really have to look for different tests. And we do have an options. Okay, but this way works perfectly. That's what this means, that limit at infinity of a sub n is 0, which means natural log of 2 and 3 minus 0, 3. It means the option A is the correct option. I can box it. Right? Please remember that's quite nice question and easy concept. Of course, easy question if we know the concept. Okay, let's keep moving. Okay, and then we learn a few things. Probably all of my questions will be like mixed of the section 11.2, 3, 4, and 5, and 6. Okay, that's me because I can't. Yeah, it's just better to have this variety. Okay, that means we do have 4 different series, and we have to determine which one is convergent, which one is divergent. At the moment, no absolute, no conditional convergence, just the convergence or divergence. Okay, that's my first one. Who can tell me? Is this infinite series convergent? Summation 1 over n to the power of 3/2. Oh, we should be quite, yes, quite. I mean, I know that you will practice. Remember, without practicing, yeah, it's kind of like, yeah, it's not, practice will give you confidence. Yeah? And if you have confidence, your potential opens. And then you will see, you will like go through nice and smooth through your test. Okay, I see 3 over 2, 3 over 2. Yes, thank you for answering. It's more than 1, and this means that by the P series test, this is convergent. Okay, let me box everything. That means this one is definitely convergent. Okay, what about this one? Maybe I can use different color. What about this one? 1 over n to the power of 2/3. Of course, it's divergent because now my p-value is 2/3 is less than 1. This one is divergent. What about 3/2 to the power of n? We can see n is placed in the exponent, okay? And this means, and no other n's. Yeah, like we don't have n as a base. This means is the geometric series. Common ratio is always the number taken to the power of n, which is 3/2. Unfortunately, when the common ratio is greater than 1, we do have divergence. It is, I would like just to state, divergent. I want to organize my screen. Okay, and what about the last one? What do you think? -1 to the power of n over n to the power of 2/3. It's kind of similar to the second one. However, I would say it's totally different because of -1 to the n. Since we have this component, this part, -1 to the n, we can say that it's alternating series. If it's alternating, I will try AST. I don't know if this will work, but let's try. AST, like the alternating series test, means that I have to ignore the -1 to the n and take the other part, which we will call b sub n, and b sub n is just this, okay, 1 over n to the power of 2/3, and then I have to test. B sub n must be positive, and it is positive. Great. B sub limit of the b sub n, limit of b sub n at infinity must be 0. And we can see 1 over n to the power of any number at infinity, it's 0. And I will not really prove this, but b sub n is definitely decreasing. We can see. Because if I will create another term, b sub n plus 1, it will be always smaller. If I make the denominator bigger, the whole fraction is smaller. Okay, that's we can see. Check, check, check. I am satisfying all of the 3 hypotheses. I can conclude that this infinite series is convergent. Let me write here. Convergent by AST. I will not write here. Okay, That means that's the way to check. And I believe, or maybe I do have this question. One of the questions which was on the midweek quiz, probably the last one, was similar situation, the second and the fourth one. But let's wait, because now we have to make the conclusions. Or maybe I can even ask you now, because this is the review. Okay, first of all, let's find the correct answer. We have convergence. We have convergence here. The 2 and 3 is divergent. Okay, the first one and the fourth one. The first one and the fourth one. Please. Oh, okay, okay, but now what I'm saying this. If we will give you infinite summation like that, -1 to the n over n to the power of 2/3. And now I'm asking you, is this infinite series absolutely convergent, or conditionally convergent, or divergent? Because that's the only 3 options when we talk about the absolute convergence. What do you think? We have all of the work done here. Now you just have to make the correct, it's conditionally convergent, right? Because we can see, when I take this as the original one, okay, I'm getting my option 4. It is convergent. That means this one is convergent by AST. However, when I take the absolute value, I'm just creating a series number 2, because the denominator will stay, all of the terms are positive, stays as a positive, but -1 to the n becomes just 1. And then the absolute value is actually divergent. Absolute value of my series is divergent. That means since it's not, too fast. It's not absolutely convergent, yeah, that's my conclusion. Then I still have to kind of get back to my original one. It is convergent. Then the final answer is telling me that it's conditionally convergent. Convergent, divergent as an absolute value. That's the condition. And that was the case for your midweek quiz. Okay, we have one question. How it is divergent? You asking for the blue part is here. No, we just discussed this. It's number 2. It's divergent because it's the p value is less than 1. Less than 1 is divergent. Okay. Let's see my next questions. If a sub n will correspond to the function f of n, where f of x is positive, continuous, and decreasing, we remember integral test, on the interval from 1 to infinity, and the improper integral from 1 to infinity f of x dx, it's 4, then the corresponding series is also 4, because we can see the function is the same, like this formula is the same like this one. And we remember we taking the integral, we integrating, getting a finite number, we can say, of course, it's convergent. Then I can say that the infinite series is also convergent, the corresponding one. But what about the exact value? Do you think if the integral is equal to 4, then the infinite series is equal to 4? It's false, thank you. Because we may compare them, but you probably remember I think it was my session, when we have a function and then we're thinking about the infinite series, like the rectangles, they were like smaller or higher. That means it's never the same. The convergence and divergence, this works, but the value of the area under the curve, which is 4, will be never the same like the addition of the areas of all of the rectangles. They are comparable, we can compare it, but they are not the same. Please remember. Okay, and then, We just talk about this one. What about this question? If the limit of the sequence is 0, then the infinite series A sub n is convergent. True or false? Of course, it's false. Thank you. That we can't conclude. Yes, okay, that's mean everybody. Good. We remember when the limit is 0, we know nothing. We really have to check. And always the beautiful example is 1 over n. Okay? Harmonic one. That's the harmonic, and we definitely know that harmonic series is divergent. However, limit at infinity, 1 over n is 0. That means even if the limit is 0, we do have divergence. That's the false statement. Good. Okay, let's keep working. Okay. Determine whether the series is convergent or divergent, and if it converges, find its sum. Please note that when we're asking for the sum, probably is geometric series or telescopic one, because that's the only two types that is relatively easy to find a sum. Of course, if we're talking about the convergence. Okay, that's what we have. We have infinite series 1 plus 2 to the n over 3 to the n. I see n's in the exponent only. That means this is probably the geometric series. The only thing that worries me a little bit is addition, because we do not have additions. What I will do, I will split this for 2 series. 1 over 3 to the n and 2 to the n over 3 to the n. Okay, that's mean now definitely each of them is the geometric one. Okay, the first one, I can rewrite as 1/3 to the n is the same, and this one is 2/3 to the n, because the entire number taken to the power of n, it's always a common ratio. So the common ratio for the first one is 1/3. Common ratio for the second one is 2/3. Both of them are less than 1. Excellent. We do have convergence. That means both of them are convergent. Okay, I will just put. Since they are convergent, we have to use the formula for the sum. Formula for the sum is A over 1 minus the common ratio. And we can only use this formula if the common ratio is between -1 and 1. Okay, and we do have the number less than 1. Okay, let's use it. A, 1 minus 1/3, A, 1 minus 2/3. And we will add these two values. A of course means A sub 1, the first term. Okay, who can tell me the first term? Oh no, for this series. Okay. The first term means that we're taking n equals to 1 and substituting for the formula, which means 1/3 to the power of 1. Oh no, my writing. 1/3 to the power of 1, which of course is 1/3. And I can maybe remove this one. 1/3. Okay. Who can tell me the first term for the second series? Also the first, yes, just 2/3. Good. I will replace this with 2/3. Okay, let's try to simplify 1/3 over 2/3, 2/3 over 1/3. And I think we can cancel out thirds. We have 1/2 plus 2. 1/2 plus 2 is 2.5. 5/2. We can leave it like that. Okay, but please remember to add or subtract whatever the addition, whatever the operation is, and always split for 2, because having this, the original form, it's still not really the geometric one, because I will be not able to get the common ratio. Yeah, we shouldn't have any addition or subtraction. Okay, good. That means that's the sum, 2.5. Let's look at the other. I hope I didn't make an arithmetic mistake. No, let me double check. No, okay, looks good. Now it's the same question, but different type of series. Determine convergence, and if it is convergent, find the sum. And you remember, we may only ask you for the sum if it's geometric or telescopic. That means this one looks really nice because it's the difference between two terms. And we even call the telescoping series as a method of difference. And we do have 1 over n minus 1 over n plus 1. That means we see the difference of two terms which came from the same sequence. That means this is definitely a telescoping. Yeah, it's the telescoping series. Okay, as soon as we know this, we know what's the process. It is a little bit time consuming, but again, when you practice, it will be like a breeze. That's what we need. We will do the expansion, like the partial sum. The summation, let's say from I equals to 1, and we will end with n. We know that n goes to the infinity, but I have to introduce like another index, another letter. That means this is 1 over I, the same thing, 1 over I plus 1. And now I will expand because I would like to see the sum. This will be defined for I equals to 1. This will be defined for I equals to 2. Maybe I'm taking too much space. This will be defined for I equals to 3. And we will skip a few steps. This will be defined, let me start from the, this will be defined for the last value, which is n. This is 1 before, n minus 1, and this is n minus 2. Yeah, I'm going like backwards. Okay, 1 over 1, 1 over 1 plus 1, 1 over 2, 1 over 2 plus 1, 3. 1 over 3, 1 over 4. And then 1 over n, 1 over n plus 1. Instead of I have to put n minus 1. Instead of I have to put n minus 1 plus 1 is just n. And the same, n minus 2 plus 1, minus 1. Okay, and let's see, because sometimes we will need more terms, but probably this is okay. And we know that most of them will be cancelled out. Negative, positive, negative, positive. And if I will list more terms, this will be definitely cancelled out if I will have more terms. Now let's look at the backwards. Positive, negative, positive, negative. And the same will happen with this one if I will have more terms. But what is important? Looking from the beginning, I see that my second term, both of the terms are gone, both of the items are cancelled. This means that every other term will cancel two of these numbers. As soon as one of the term, and the first term is second, because we can see this stays. We didn't cancel this one. And then, since it's the telescoping, we remember the whole story. The same pattern will happen from, like backwards, from the end. Since the first term is not cancelled, actually I would say the first number from the first term is not cancelled, the same will happen on the back, at the back side. The last term will not cancel the last number. It's like a mirror image. The last and the last one. And the rest of them will be cancelled out. That means only the blue circles are my partial sum, the formula that stays. And now we have to check how this partial sums behaves at infinity, how this behaves if n is infinity. And you probably know. Can you tell me the answer? 1 minus n plus 1. 1 over infinity is 0. 1 minus 0 is 1. Okay, that means this is the sum. The infinite series is convergent to 1. As I said, looks like lots of work, but it's not yet. It's relatively easy. Good, that means we know geometric one, we know telescopic one. Let's keep moving. Okay, now just the random formula. And we have to determine convergence, divergence, or divergence, and we have to state the test. Infinite summation from 1 to infinity, n over cube root of n to the power of 4 plus 1. Okay, that's me what we see. We see definitely a formula with all of the positive terms. And on the top, I have power function, and in the denominator, I have power function. Definitely, I will try direct comparison or limit comparison. Because I can compare, because I do not have negative terms, and it's perfect for comparison. What I will compare with? With the highest power. Okay, and since plus 1 is making denominator a little bit bigger, the whole fraction is smaller. And that means let's see if direct comparison works. I have to simplify. This is n to the power of 1. This will be n to the power of 4 over 3. When I subtract 1 minus 4 over 3, I have negative 1/3, which means it's positive 1/3 in the denominator. In what we have on the right-hand side, just comparing, we actually have the p-series test 3, which is less than 1. It is divergent. Okay, that means having this series divergent, everything what is smaller, we don't know. Correct? That means this means that we can't really use direct comparison. It's not working. It's definitely not working. Okay, but I still have to check my limit comparison. Oh, no, too fast. Limit comparison, which means I will compute a limit of my original formula over the new one. That's the new one. And check if this limit will give me a positive finite number. Let's check. This is n. This is, okay, I can actually copy everything. And dividing by this, I will multiply by the reciprocal. Okay. Okay, we have a question. So if it's divergent, you cannot use direct comparison. Oh, I don't know if I understand your question. You asking for this? Because my infinite series on the right-hand side is divergent. Okay, and we remember if something is if I have divergence, everything what is smaller, I don't know. Yeah, if something, because divergent means like, to really saying really simple, divergent means like infinity. This summation goes to the infinity. Something that is smaller also could be infinity. We don't know. Okay, but the thing is, if I have divergence and this will be relation this way, if I have infinity, everything what is greater than infinity, of course, is infinity. Then I can conclude divergence. But unfortunately, my relation is this way. Okay, that means that's the reason that we can't use. We can't use the direct. Will be just wrong test. Okay, but let's look at the limit. And you probably notice for the limit, this is power 1, this is power 1. This is power 4 over 3 times 1. This is also the highest power 4 over 3 times 1. That means the powers of n, they're exactly the same. Coefficients 1, the limit is 1, because the powers are the same. And this, I'm just looking for the number greater than 0, limit comparison test. If you have your summary in front of you, you will see this. Okay, since this works, I can conclude my convergence, divergence. If B sub, oh, my pen. if B sub n is the B sub n series was divergent, then my original series behaves the same. That means it is divergent by limit comparison test. Okay, because this, no question mark, this works. Okay. Oh, I believe this one is probably a little bit different than your midweek quiz, but similar. Okay, this one is similar. Actually, oh, no, because the midweek quiz asks for the conditional convergence. Do I have this? Oh, no, I didn't copy. It's okay. Okay, that means first of all, what I see this. Yeah, it is quite a long formula, but I will be not worried because I only focus, in terms of the ratio of two polynomials, we only focusing on the leading terms. We know algebraically all of them will disappear. Okay, that means first of all, I have -1 to the n. I can probably use AST. Oh, but let me not state this because if we're not satisfying the condition, then I can't use the AST. Okay, AST, which means I'm just taking the formula B sub n, which I can, for now, I can copy. Okay, and now I'm testing. This formula is definitely positive. Okay, definitely the limit of B sub n at infinity is 0 because denominator is winning in terms of the degree of the function, and definitely B sub n is decreasing. It's just polynomial, nothing fancy, and denominator grows faster. That means this will be decreasing. Check, check, check. That means this is infinite series convergent by AST. Okay, done. However, when we add this extra part, is this infinite series absolutely convergent, conditionally convergent, or divergent? Then what I have to do, I have to take, because I did test, it is convergent, but let's check if it's absolutely convergent. This means, or maybe conditionally. I have to take absolute value. Taking absolute value, I am changing my formula. I mean, I will keep the same formula, only -1 to the n disappeared. Oh, my writing. 2n to the power of 4 n cube. It's actually -1. N to the power of 5 plus n cube plus 6. Okay, that means now I'm not allowed to use AST because I don't have alternation, but the only thing that I can try comparison because now all of the terms are positive. That means I will try to compare, I should make a little bit of room, to n to the power of 4 over n to the power of 5. And this is my original one. Let me just put a sub n. Because I just took this. But now for this one, since we can see, we're adding terms to the numerator, we're adding terms to the denominator. I don't really know if my original formula is greater or smaller. Okay, that means I will not even risk, I will not even try direct comparison. I will try the limit comparison right away. Okay, and the limit comparison, you probably know the limit, but let me write this. I will divide my original one, cube n minus 1, okay, n to the power of 5, n to the power of 3 plus 6. And dividing by b sub n means multiplying by the reciprocal. Okay. And now the limit at infinity, in terms of the polynomials, the ratio of two polynomials, we need a leading term. And when I multiply each term, n to the power of 5 times n to the power of 4, and n to the power of 4 times n to the power of 5, I have exactly the same degree, n to the power of 9. With the leading coefficient 2, the limit is 1. And if the limit is greater than 0, the limit comparison test works, okay? However, works, but we have to make the conclusion. My original series will be exactly the same like the new one. Can you tell me if this, or shall I use different color? If this green circle, if this series is convergent or divergent? Because my original will behave the same. It's divergent, thank you. We know why. Because it's n to the power of 4 over n to the power of 5. By simplifying, I am making just 1 over n. And the 2 somewhere we don't even need. And 1 over n is divergent. That means since this one is divergent, the blue one is also divergent. That means this one is divergent, which means absolute convergence is gone. It's not absolutely convergent. Okay. However, what are the final answer? It is conditionally or it is divergent? Can you tell me? Is this original? It's conditionally convergent. Because not absolutely, but the original one was convergent. Okay. So remember, for the conditional convergence, we always have original formula convergent, but not absolutely convergent. Yeah. Okay. Why did you multiply by n to the power of 5? Oh no, this is my limit. I can state here, limit comparison test. Okay, you have to review your 11.7. It's a sub n over b sub n. Yeah, I'm testing this limit. This was a sub n, and b sub n is this one, the new one. That means instead of dividing by fraction, I multiply by the reciprocal. Yeah, I flip this fraction. Yeah, I just, yeah. Okay, let's keep. Okay, convergent or divergent? What test we use? Negative 1 to the n over ln of n. Who can tell me? Probably you can see right away. What test we can use? Yes, but let's just put with the question mark, because if we're not satisfying all of the three conditions, then we can't use it. Okay, but let's assume. Okay, AST because negative 1 to the n. My b sub n formula is just ln of n. It's definitely positive. Limit of b sub n at infinity is definitely 0. And actually b sub n is definitely decreasing. Check, check, check. Convergent by AST, no question mark. Nice and simple. Good. I don't know, but I still, what do you think? If I will steal first and ask you this, can you tell me right away? Do you think it's absolutely convergent or conditionally convergent? Of course, this is not an option since we have convergent. Okay, Ari Yaman is saying that it's absolutely. Okay, let's check. We have to take absolute value, and my formula becomes like ln of n. Oh, this is supposed to be 2, because ln of 1 is 0. Okay, I will try, because now all of the terms are positive, I will try, or maybe I can use the red color because the blue, I will try to use comparison, because that's the good 1 over n. We know that natural log is less than n, natural log of n is less than n. If the denominator is smaller, the whole fraction is bigger. And what we know about this one? This one is the harmonic. Divergent, everything what is bigger is divergent. That means this one is actually divergent. Yes, it's actually conditional. Because when we have divergent for absolute value, this option is gone, but we do have convergence. It's again conditionally convergent. Always for the conditional convergence, we have a little bit more work, but nicely it's, let me remember, convergence and divergence. Then it's conditional convergence. Okay. Oh, look at this. I planned this. Yeah, we just did it. This, yeah, the second part, the right-hand side of that slide answers this question. Okay, what else I have? Oh, absolutely convergent, conditionally convergent, or divergent. 5 to the n plus 1 over n factorial. What test will be perfect for this combination of like everything? Of course, ratio, yes? We know that when we see like power, that's power, n plus 1. Like n, power function, 5 to the n, exponential, factorial. If we see like a few different types of expression, always the ratio is a good choice. Ratio test. And let's do it. I like to do ratio test because it's like lots of cancellations. A sub n plus 1 over a sub n. And infinity. I can ignore absolute value because all of the terms are positive. Okay, n plus 1, that means we have 5 to the power of n plus 1, n plus 1, n plus 1 is 2, n plus 2, and n plus 1 factorial. Dividing by a sub n, I will multiply by reciprocal. Okay, and let's see what limit we have. Limit, okay, 5 to the power of n, 5 to the power of 1, n plus 2, n factorial, 5 to the power of n, and maybe I can put n plus 1 here, and now the factorial, n plus 1 factorial, I can rewrite as a n factorial times n plus 1. Yeah, it's like let's say 7 factorial. I can rewrite as a 1 number less, 6, and then times 7. Okay, and what we can cancel? We can cancel this, we can cancel this. And what stays? Limit, and goes to the infinity, and we have 5 n plus, okay, I can distribute this. And then we have n plus 1 and another n plus 1. Okay, what is this limit? We have a ratio of two polynomials, n to the power of 1 is the degree on the top. What is the degree in the denominator? It's second, yes, thank you, Ramiro. That means we have n to the power of 1 versus n squared. Denominator is winning. If the denominator is winning, always 0. And 0 is actually a good number because 0 is, excuse me, it's less than 1. Okay? Because that's what we're looking. We're looking for the convergence. We're looking for the number less than 1. If the number is less than 1, we can say the infinite series is absolutely convergent by the ratio test. Because the ratio test and the root test only tests this. Okay, if the number will be greater than 1, then it's just divergent. And please remember, using the ratio test, if you get the number greater than 1, it's just divergent. You don't have to test for conditional convergence because it's just a special test, just this special ratio is giving me right away that conclusion. Okay? That means probably the ratio test is not really, if it works, of course, because we remember when the limit is 1, then the ratio test doesn't work. But the ratio test will always work for this type of formula. Okay, and then another nice test. I mean, another nice formula, and you will tell me what test to use. negative 1 to the n squared to the power of n, and 3n squared plus 1 to the power of n. Almost everything, it's taken to the power of n. We can see n and n. That means what test is good? Of course, the root test. Root test. Okay. I can maybe rewrite a little bit. Negative 1 to the n squared, 3n squared plus 1, and everything to the power of n. And now the root test, it's asking me to take the nth root of the absolute value of a sub n. Absolute value will remove that part because this will become positive. That means I can only focus on the other, on the main formula. Nth root, and I can copy my formula. Oh, too fast. Okay, that means the power n and the root n can be cancelled out. And what is the limit? N squared over 3n squared? It's of course 1/3. Again, really nice. Number is less than 1. That's what we want. We have, again, absolute convergence by the root test. If the number is greater than 1, it's just divergent. No point to check for conditional convergence. Okay, that's also a nice test. Okay, and I believe, hang on, let me check. I believe this is my last example. However, no, let me check something. Oh no, I do have one more thing. The alternating series, like estimation theorem. Okay, we did have this. And let's maybe solve that's let me come back to this was my last example. And again, taking all of the sample test and the practice test, additional practice, you will see all of this kind. That means please practice, please like solve them. You have the full solution provided. You can, of course, you can put your questions on the discussion board, and I will always try to answer. Okay? But you have almost all of the solutions. That means please practice, and you will see how the actual test will be nice and easy for you. But you have to practice. Okay, that means let's solve this one. And this will be the last question. Okay, consider the alternating series, negative 1 to the n, 16 over n to the power of 4. From the list of numbers given, right, that we have a little bit of limitation. Choose the smallest. Choose the least number of terms necessary to ensure that the difference between the actual sum S and the partial sum S sub n is less or equal to 1 over 10 to the power of 4. That's what we're saying. We're saying that the difference between the actual sum and the partial sum must be less than 10 to the power of 4. Okay? Of course, this infinite series is convergent. We can see by AST is convergent because 16 over n to the power of 4 is positive, limit 0, decreasing. Since it's convergent, the sum exists, but we don't know what is the sum. But we know that the difference between the actual sum and the partial sum, okay, it's always less than or equal to b sub n plus 1. That's what we're testing. Okay, that means always that error, that difference. Like if let's imagine that this is my entire sum, and then I'm only taking a few terms, like let's say 10 terms. That means I do have this difference because I'm skipping a lot of terms. But we know that this difference, this remainder, this error, it's always less. That value, it's always less than the b sub n plus 1, the term that we didn't use. Because in order to get s sub n, we're just stopping at b sub n. Okay, that's we know the theorem. and was nicely covered before in our weeks. Okay, that's what we have to do. We only have to focus on this. My formula for B sub n of, it comes from my series, which is 16 over n to the power of 4. And now I am looking for the term that is less than that error, 10 to the power of 4. Okay, and normally what I will do, I will start with B sub 1 because that's what I have to find the term. Okay, I have to find the term that is less than this. Let's work on the n numbers. Normally I will start like B sub 1. B sub 1 is 16 over 1 to the power of 4, which is just 16. 16 is way bigger than my error. I will then keep working B sub 2. 16, 2 to the power of 4. Actually, it's 16. 16 over 16 is 1. 1 is way bigger than 10 to the power of 4 in the denominator. But we can see, because 1, 2, 3, 4, and so on, that's my n values. But we can see, based on these values, probably I have to start with the biggest value. Okay, that means I'm not testing 3, 4, 5 because it will be still not good. Because what I'm looking for this inequality to change the direction. Then I can work out my answer. Okay, let's take 10, since 10 is the first one on the list. 16, 10 to the power of 4. But my error is 1 to the power of 4. Okay? Then this is still bigger. Okay, let's take 20. Because that means this is probably, oh, no, let's still, no, don't make, because we still have to play with n and n plus 1. Okay, I will take 20. 16, and then 20 to the power of 4. 16, 20 to the power of 4 is 2 to the power of 4, and 10 to the power of 4. And actually 16 and 2 to the power of 4, that's 16. That means, B sub 20 is exactly the same, like the error, but we may accept this. Okay, that means this means that the 20th, right, the 20th term is satisfying this. Okay, that we can see the 20th term is satisfying, which means this, I can consider this as a 20. That means if this is 20, what is the n value? What is the minimum value? Like what will be the n value here? If n plus 1 is 20, what is n? You remember, it's always here, always one number less. It's 19. That means I can say that the least number of terms, it's actually 19. Actually, any number of terms, 19. Any number of terms equal to 19 or greater than 19 will satisfy this. Because now you can imagine if I will put B sub 21, B sub 22, definitely all of the, because I am increasing denominator. When I am increasing denominator, the whole fraction is smaller. That means I will definitely have a proper like inequality, smaller values. Because as soon as I increase my denominator. But however, 20, B sub 20 is the lowest number, which means n19 is the lowest number. N equals 19 is the lowest number. That means now, when 19, because this is, actually I can put 19. If 19 is on the list, why this is switching? What answer will you choose? What is the correct answer now? Can you tell me? It's A. Because even, yeah, you can see, because this is always a little bit confusing. Even if B sub 20 works, because this is the first number that works, we always have to choose number one less, 19. Okay, that means 19 will be the correct answer. But they asking us to choose from the numbers provided. Let's say the 19 is not here. What is the smallest number that's satisfying this? What is the option now? Of course, 20. Yeah? Because theoretically, any number is good. Because even if I increase number of terms, I am minimizing my error. That means I will be in that range of the error. Yeah, the error will be definitely. But they asking for the smallest number. That means the smallest number provided is 20, which theoretically should be 19, but it's not given. That means I have to pick the smallest one. No, 18 doesn't work because we can see B sub 20. B sub 20 works for my property from my theorem, which means 19. 19 is of course, 20, one number less, 19. 19 is the lowest value. Okay, 19 is the lowest value. If you would like to, if we will pick the number 18, then 19 should work. But when I put 19 to the power of 4, the number will be still greater than my error, which doesn't work. Okay, no, only this, all of the numbers, that's the answer. All of the numbers equal to 19 or greater than 19 works. But we're looking for the smallest one. The smallest one is 19. 19 is not provided, then the answer is 20. Okay, you can check. I think it's I solved similar problems in each sample test, each practice test includes this question, this type of question. Okay, where is my camera? I can switch off the camera. Okay, I solved all of these problems. You can definitely review these problems. Also in the announcement, I put like my old review session. You can also check because maybe I'm solving a little bit different problems, but this was the set number, good set of problems. Do not miss any question because do you remember the last review? Yeah, some of the questions from the review session were so similar to your actual test. Okay, that means good luck with your review and please practice every day. Okay, today a little bit, of tomorrow, and tomorrow the test is open, but if you have more time, if you make your appointment a little bit later in the week, you still have a little bit of time. Okay, thank you very much for joining me.